Woohoo! Welcome back. Tonight we're going to be talking more about polynomials and their zeros and division. Yay! And our friend Sharktopus, who is both smooth and continuous, is here to help us out. Okay, so we're going to start off with the factor theorem. Woohoo! This is a really big deal. For us, it's going to feel like it's maybe not as big a deal, but it becomes a bigger deal as you go further along in math. And it is one of my favorites because it has an if and only if in it. I love those. So C is a 0. So in other words, when you plug C in, you get a 0 as your answer. If and only if. Remember, this goes in both directions. And it is written IFF. It's so cool. So C is a 0 of P of X. If and only if, X minus C is a factor of P of X. So if C is a 0, then that is a factor. If that is a factor, then C is a 0. So if X minus C is a factor of P of X, then P of C equals 0. If C is a 0 of P of X, so in other words, P of C equals 0, then X minus C is a factor of P of X. So this is a one-to-one correspondence. If you're a 0, then you're a factor. If you're a factor, then you get a 0. It's awesome. So how do we use this? Well, in I think a very exciting way. If I say find a polynomial of degrees 6 with zeros 2, -1, 5, 0, 0, and -3, my polynomial is, and you could choose, there are a lot of them, x minus 2, x plus 1, x minus 5, x minus 0, x minus 0, and x plus 3. Now, where did those come from? Well, if I know what the zeros are, the 0 is 2, -1, 5, 0, 0, and -3, then I can create a polynomial of degree 6, 1, 2, 3, 4, 5, 6 factors. So we're going to end up with x to the 6th, because I have baked in all of these zeros. So that's basically what we can do. We can create polynomials that have certain zeros, which is going to be great for modeling later on. Woohoo! Now in this class, we're not going to do a lot with this. We're just going to look at it, say, isn't this cool, and move on. But later on in math, there's a lot we can do with it. So yay! Okay, so having said that, where are we going to go? Dun, dun, dun! I know, you see, long division. So the other thing we're going to talk about in this chapter is all about division. Now, there is something called long division, which is the division we were doing earlier in the previous videos. And that's where I go ahead and write out division the way you're probably used to seeing it. I've got 3x to the 4th. minus 5x cubed plus 0x squared. Remember that sneaky thing we do if there's a missing term? Minus 20x minus 5. So I've got all of my terms written in descending order. And then what I do is I say, okay, I'm going to look at the x, and I'm going to look at 3x to the 4th. And I think, what times x gives me 3x to the 4th? And I say, oh, 3x cubed. So then I've got 3x to the 4th minus 6x cubed by multiplying out, right? This is 3x cubed times x minus 2 goes right there. And then what do? Then I come through. Let me try a brighter red so it shows up a little bit better. And then what I do is I change the signs. Everything that was a plus becomes a minus. Everything that was a minus becomes a plus. And then I add. 3x to the 4th minus 3x to the 4th is 0x to the 4th. And then this is negative 5x cubed plus 6x cubed gives me just x cubed. Okay, next up, I look at x cubed. I bring the 0 x squared down. And I say, what times x gives me x cubed? Oh, x squared. Then I multiply. X squared times x is x cubed. X squared times negative 2 is negative 2x squared. Okay, so this one is going to be x squared times x minus 2. Pardon me. And that goes right there. And again, change the sign. That becomes a minus. That becomes a plus. This together gives me 0x cubed. This gives me 2x squared. I'm going to have to move this part down. I'm covering something up so you don't worry about it. There we go. Because I'm going to need a little bit more room. I bring the negative 20x down, and then I think, okay, what times x gives me 2x squared? 2x, you got it. So then I multiply 2x times the quantity x minus 2, and that's going to go right here. 2x times x is 2x squared. 2x times negative 2 is negative 4x. And I'm going to change the signs. I'm going to add 0x squared. Oh, this one's a little bit ugly. I get negative 16x, and I bring the negative 5 down. And then I think, okay, what times x gives me negative 16x? Negative 16. So then I've got negative 16 times x minus 2. That's going to be negative 16x plus 32. Change the signs and add. And then my remainder is negative 37 because I've run out of x's. Okay, well, as you might guess, after doing a billion, million, trillion of these, a lot of mathematicians were like, wow, that kind of stinks. I wonder if there's a shortcut. And the answer is, ta-da! Very exciting for all smooth and continuous creatures and the rest of us. There's actually a shortcut. Y'all ready? Okay, very exciting. This is called synthetic division. And there are lots of ways for me to try to describe it, but the best way to describe it is for me to show you. So, and here's the thing. I know for a fact that there are a million billion different ways to write this. So I'm going to show you the way that I was shown how to do synthetic division. There are slight variations. Feel free to use whichever notation you like, whichever one makes the most sense. So I was told to make a little box here. And because I've got x minus 2, what goes right in here is positive 2. Now you're going to say, wait a minute, why isn't it negative 2? And the answer is partially that's the 0, and partially because remember this point where we multiply and then we change the sign? We've changed the sign, so it's built in. Then what we're going to write right here are the coefficients: 3, negative 5, 0, negative 20, and negative 5. A lot of people are deeply suspicious at this point. They're like, this does not seem like a shortcut. And trust me, see how long this is? See how much work it was? One of the things we're going to do to make this a shortcut is you notice we're not writing in the x's. So it's going to save us a little time. Because of this, we need to be really super careful. There are no x's to make sure we don't mess up. So make sure these are exactly in order, descending order, and nobody gets skipped. So see how that 0x squared had to come in here? We need to put the 0 in there. Okay, having done that, I draw a long line underneath. And now this is the process, and it's a little bit weird So I'm going to give you a couple examples in this video, and there's another video with another example, and then it may be that you have to ask lots of questions, and you're going to say, oh my goodness, can you show me again? And so we'll just keep practicing it till it makes sense, because it's a great shortcut. Watch how fast this goes. Okay, the 3 comes down. Automatically, we just get the 3. Then we're going to multiply the 3 times the 2 and get 6. And then we're going to add down. As you're coming down, you're going to add. -5 plus 6 is 1. 1 times 2 is 2. 0 plus 2 is 2. 2 times 2 is 4. -20 plus 4 is -16. -16 times 2 is -32. -5 plus -32 is -37. So you got to kind of get into the groove. The 3 comes down. 3 times 2 is 6. Add down. 1 times 2 is 2. Add down. 2 times 2 is 4. Add down. -16 times 2 is -32. And add down. And then if you look here, and you look at all this mess, and then you look up 3x cubed plus 1x squared plus 2x minus 16, remainder 37. Same answer. So this becomes, even though this was the x to the 4th up here, it becomes the x cubed, because we're going to reduce it by 1 degree. So this was the x cubed, this becomes the x squared. This was the x squared, it becomes the x, because we're dividing out an x, so everyone loses 1 level. This is the x, this is the constant. And then this is the constant up here, and this is the remainder. So it's 3x cubed plus 1x squared plus 2x minus 16, remainder -37. And that's how you do it. Okay, next up, we have to remember something from the previous video to answer the next one. Oh my goodness, everything's just rock and rolling today. If p of x equals this thing that was way up here, that's down here, if p of x equals 3x to the 4th minus 5x cubed, right? You can see it right there, minus 20x minus 5, use your previous work to calculate p of 2. Now, I could take 2 and I could plug it in. But remember, there's a formula from back before that p of 2 is the remainder when p of x is divided by x minus 2, which is exactly what we just did here. So we do quickie synthetic division. The remainder is -37. So p of 2 is -37. Woohoo! So not only can we do quickly dividing, but we can do quickly calculating without a calculator, which is pretty cool. Now, every now and again, someone asks me straight up, could we please just use long division? And the answer is sure. You can always, long division will always work. Synthetic division only works in a special situation. If you have x minus a number or x plus a number. If you're dividing something else, it gets very, very complicated. So I don't recommend it. It is hard to do when there are other situations. Now, are there other forms of synthetic division that you can look up? Yes, I will help you look them up. But in my experience, they aren't as successful. So long division is generally a good idea unless you have x minus 2 or x plus something. So, shall we try it again? Woohoo! Yes! Yay! Okay, so we're asked to divide using synthetic division. So we want 3x squared minus 7x minus 20 divided by the quantity x minus 4. Okay, so first check. Synthetic division works if it's x plus a number or x minus a number. Good, that's what we've got. So in the box, we put whatever the opposite, whatever c is. This is going to be 4. Then to the right of the box, we put the coefficients of this polynomial. In this case, it's 3 minus 7, negative 20. And I draw a line. And again, are there other forms for synthetic division? Absolutely. So the 3 comes down. 3, just the first number always comes down. Then you multiply. 3 times 4 is 12. Negative 7 plus 12 is 5. 5 times 4 is 20. Oh my goodness, this is very exciting. So remember, this was the x squared, this was the x, and this is the constant. So down here, this is the x, this is the constant, and this is the remainder. Everyone goes down by 1. So the answer is 3x squared minus 7x minus 20 divided by x minus 4 is equal to 3x plus 5, remainder 0. Now, why is this nice? Well, now if you can do synthetic division, you can check factoring really quickly. Woohoo! So in other words, x minus 4 times 3x plus 5 multiplied together give us 3x squared minus 7x minus 20, which is really cool. And that leads us to our final question, which is, how would you check for zeros using synthetic division? So since the remainder here is 0, that means x minus 4 is a factor, and that means 4 is a 0. So if the remainder equals 0, remember from our previous sheet, do I have it handy? If the remainder is 0, then x minus c is a factor. And if x minus c is a factor, that means that p of c equals 0. So what are we going to look for? We're going to look for the magical 0. If the 0 shows up in the remainder, then, like in this previous problem, x minus 4 is a factor, and p of 4 equals 0. It's a 0. Woohoo! Okay, so that was a lot. It was a lot in a shorter video, but there's still a lot going on. So definitely take a break, get something to eat and drink, and then get started on the homework. Ask lots of questions, because this is some weird, new, interesting stuff. And we're mostly going to focus on it in this chapter. We don't really get to go a lot further, but in later math you will get to. So this is just setting some foundations for some later work, and it's very cool. I think it's really a lot of fun. So ask lots of questions. If you're feeling frustrated, if you're feeling lost, please ask questions, because you are brilliant, and we don't want to waste that amazing brain space on feeling frustrated. Ask the tutors, ask me, let's get you all set up so that you can go through it, and so that you can go bam to bam, 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 and you're done. Woohoo. Math on, guys. Enjoy.